Here are two parallel lines, and now I'm going to add a line that traverses them, or in plain English goes across them. And we call this a traversal. Now if I draw an angle between the inside of the parallel line and the traversal, the alternate angle says it will be the same angle between the inside of the other parallel line and the traversal, but on the alternate side. So since this is above the traversal, the angle will be below the traversal, and they will be the same. I'm going to draw a line between the inside of the other parallel line and the traversal. And again, the alternate angle will say that the angle between the inside of the other parallel line and the traversal will be the same on the alternate side. So since this is on top, we'll go underneath. And these will be the same. More often than not, you won't get to choose. You'll be given an angle. And this angle is between the inside of the parallel line and the traversal. So I can use the alternate angle theorem. So I go to the angle that is between the inside of the other parallel line and the traversal, but on the opposite side. So since this is above, we'll go below. And this will be the same angle. And we must write alternate angle whenever we use this result, just to prove we didn't just guess. Now this is interesting. We have two traversals, so it's important we keep track of things. Look at this angle. It is between the inside of the parallel line and the traversal. So we can go to the other parallel line and look at the angle between the inside of this parallel line and the traversal, but on the alternate side. Since this is below, we'll draw it above. And we'll justify our use of that theorem. This angle here, again, it is between the inside of the parallel line and the traversal. So we'll go to the angle that is between the inside of the other parallel line and traversal, but on the alternate side. So this is underneath, so we'll go above. And just as before, we will justify our use.